Okay, so this video is about exponent rules of algebra. First rule we have to know is this. If I gave you x to the fifth power, the expanded version of x to the fifth power is x times x times x times x times x. Or you have them multiplied together 5 times. So that means x to the fifth power. That goes any power. So it'd be third, fourth, or whatever. It means multiply by itself that many number of times. Alright, that's with that's one exponent rule. Another exponent rule is this. If I gave you x to the fourth power divided by x to the second power, what that basically means, the long way of doing it would be x times x 4 times in the numerator, and then x times x twice in the denominator. If you actually did it this way, these x's cancel to be 1's, and this pair of x's cancel to be 1's. So in my numerator, I just have 1x to the second, and the denominator, I only have 1. So our answer there is x to the second power. That'd be the answer for that problem. But truthfully, I really wouldn't work that out that way. I would just look at this, and I would decide what was the difference between the exponents 4 and 2. Well, the difference between those two is 2. Because if you subtract it, you get 2. Now, because we have more x's in the numerator, because it's x to the fourth power in the numerator, I know it's going to be x to the second power is my answer. So I can do that without having to expand it each time. But this works no matter what. So if you're ever confused or you forget any rules, you should go back to the most basic way of answering it, and you'll always be right. Alright, give me a new one. And the new one's here. The new one says, suppose I gave you 3y to the fifth, z to the seventh, over 3y to the second, that's a 2, z to the 10th power. So if I look at this, I know that these 3's will cancel. I'm going to look at the difference between all the exponents with the same variables. So these 3's will wind up canceling out, become 1's. And y to the fifth over y to the second, they cancel to just be y to the third in the numerator. Z to the 7th over z to the 10th. I got more z's on the bottom, and the difference is 3. So that means you give me z to the third in the denominator. So in the numerator, I have a 1, and then y to the third. In the denominator, I only have a 1 z to the third. So our answer is just y to the third over z to the third. So that'll be the final answer for that one. Let's do another one just like that. Alright, pause for a minute. Pause the video. Copy down this one example. You can give it a shot on your own, but in a moment we're going to talk about it. So pause the video and give it a shot on your own. Alright, hope you gave it a shot. Let's do it. Looking here, 24 over 12 reduces. And that gives me just 2 in the numerator. That becomes a 1. X to the second over x to the 6th has a difference of 4. And the biggest number is in the denominator, because x to the 6th is in the denominator. Here, y to the 5th over y to the 4th, their difference is 1. So that means y to the 1st on top. And z to the 6th over z to the 9th. The difference is 3. Gives me z to the 3rd on the bottom. So on top, I have, this is all going away. I'll only have 2 y to the 1st left. On the bottom, all this stuff is going away. So there's only 1 x to the 4th and z to the 3rd. We usually don't write the 1. So we just call this 2y, x to the 4th, z to the 3rd. That'd be the answer for that one. I'm going to give you a new one. It's going to be slightly different. In the new one, I have this problem. Pause the video for a moment and write it down. You don't have to try it on your own just yet, but do write it down. If you pause it and have it written, understand this. If you have a negative exponent, that means you go across the division bar to make it positive. So since I have a b to the negative 3, to begin the problem, I'm going to first move this to the other side of the division bar. Even if it was on the top, if that was a b to the negative 2, I bring the negative 2 to the bottom of the division bar, make it b to the positive 2. So this is better written as 5 over 7, a to the 4th over a to the 5th, b to the 2nd, and that comes in the top, becoming b to the positive 3 now. So from there, I can reduce what we can. The 5 over 7 doesn't reduce. And a to the 4th over a to the 5th, I got more a's in the denominator, so these cancel. A to the 1st. B to the 2nd times b to the 3rd, well, that's a new property. When you multiply these together, you add the exponents. So it becomes b to the 5th. So our answer should be 5 over 7. It's a to the 1st in the denominator, and b to the 5th power in the numerator. I'll explain these problems now. So let's talk about multiplying numbers that have different exponents. Alright, suppose I gave you a to the 3rd times a to the 5th. The long way of doing it is calling this a to the 1st times a to the 1st times a to the 1st, and then 5 more. This is the first 3. Then a times a times a times a times a. This is the next 5. If you notice, we got 1, 2, 3, 4, 5, 6, 7, 8 a's. So our answer is a to the 8th power. Truth be told though, I wouldn't do that every time to do it. The rule is simply add the exponents. So it's a to the 8th power. So we multiply numbers with the same base. Our base is the number being raised to the power. We multiply numbers with the same base, you add the exponents. Again, they have to have the same base. For example, if I gave you 7 to the 2nd times 7 to the 3rd, then both bases are 7. So our answer is 7 to the 5th. That is not true if the bases are different. For example, if I gave you 7 to the 2nd times 5 to the 3rd, you can't call that 7 times 5 to the 5th. That would be false. So in this case, you have to multiply that and get 49 and figure out what that is. But there's no rules of multiplying that together like these. All right, let's go on. In a new example, it says a to the 7th times a to the 11th. Well, you should know this is a to the 18th power. Here, I got b times b squared times b to the 5th, c to the 3rd times c to the 9th. That should give you b to the 7th times c to the 12th. One last example is this. All right, so the first one is our power to a power rule. This is my last example. If you got an exponent raised to a higher exponent, you simply multiply those exponents. So this is going to be a to the 6th power. The reason why is this really means a to the 2nd, b to the 5th, times c, times the same thing 3 times. So it's that same thing 3 times. I put a dot here, but truthfully, all of these get a dot, as in multiply together. And truthfully, between these parentheses is another dot. So truthfully, I can rewrite these all without their parentheses around them, like this. We're going to multiply all the a's. After I expand it all to all be multiplied together, multiply all the b's, multiply all the c's. So a to the 2nd times a to the 2nd times a to the 2nd is a to the 6th. B to the 5th times b to the 5th times b to the 5th, b to the 15th. And c times c times c is c to the 3rd. Nobody really does it all the way that way, unless they're trying to prove that they're right. Truth be told, we simply take the original problem and multiply each exponent by 3. So it becomes a to the 6th. 5 times 3 is 15, so b to the 15th. There's no exponent on the c, but there's an understood 1 there. So 1 times 3 will be c to the 3rd. A lot faster way of getting that answer than expanding it. All right, one last example. This is it. Pause the video and you try this one. So again, pause it, give it a shot, and see what you come up with. If you gave it a shot, you should have saw the exponent on 6 was 1. Exponent on a was 2. Exponent on x was 1. So this becomes 6 to the third power, because 1 times 3 is 3. A to the 6th power, because 2 times 3 is 6. X to the third, and y to the 21st. That's all I have. Good luck.